All right, let's look at continuously compounded interest. I'm not really sure why this book puts continuously compounded interest in this section, but that's where they put it, so we'll talk about it now. Um, let's look back at quiz 5. Um, we had this problem where we invested $1,000 at 5% interest, and we had to figure out how much it would be worth after 10 years using compounding annually, quarterly, monthly, and daily. And so looking at that, there was a bit of a jump each time. It continued to get larger, but it didn't continue to get a lot larger. The increase wound up getting smaller. So like going from monthly to daily compounding, it made a difference of like $1.66, it looks like. And so after a while, increasing the frequency of compounding doesn't really affect it much. And so problem 2, I ask, based on your answers to problem 1 and other knowledge you might have, do you think there's any value of n that would bring the accumulated amount to 1650 in 10 years? Because this is getting close to 1650. Everybody got this right. The answer is no. The thing is, if you try larger and larger values of n, the amount will never exceed this amount here. And one person on the quiz even put in and compounded it by the minute, and their amount wasn't, I don't remember if it was exactly this, it might have been a penny less or something, but after a while it doesn't, compounding more frequently doesn't help. If you just, so if you take the like period between compounding and shrink that down to 0, you get what's called continuously compounded interest. And that's the limiting case. And that's what we've got here. The formula for continuously compounded interest is accumulated amount is principal times e to the RT. And you might say, where does this come from? Well, if you take the formula here for compounded interest n times per year, and you let n run to infinity, you get this formula. Now I want to show you that on Desmos. What I've got here is I've got the compound interest in red, and I've got the continuously compounded interest in purple. And just looking at this graph, let me slide it over here where it's visible. It doesn't look like there's a big change in it, but notice this is t is supposed to be years, and so before it really takes off, it takes a few hundred years. So let's zoom in to the graph down here. After, well, let's look at 10 years. So 10 years, this is the difference: $1.21 here and $1.22 there for the continuous. The thing is, if n grows large, let me get this to something more manageable. Let's say up to 50 times per year. When n grows large, the bigger n gets, the closer that the red graph, the one compounded n times per year, it gets closer and closer to the continuously compounded interest. Both of these, by the way, have $1 for the principal. So anyway, so that's how we would do continuously compounded interest. Let's look at an example. Suppose $800 is invested at 2% compounded continuously. How much will it be worth after 3 years, and how long will it take to grow to 900? All right, well, these are continuous, so we're going to use our PERT equation. So 800 is our principal. So in the PERT equation, we don't have an n to deal with. So how much will it be worth after 3 years? Let's see, the principal was 800. We're trying to figure out what it's worth. Rate is 2%, and we're saying after 3 years. So to answer that question, it's just going to be 800 times e to the 0.02 times 3. 800 e to the 0.02 times 3, $849. And let's see, 46.9 cents, we'll round that to 47 cents. All right. And now the second question, how long will it take for it to grow to 900? So on this, you're still starting with 800. The rate's still 0.02. This time we're asking, how long will it take to grow to 900? So we'll just plug in 900 equals 800 e to the 0.02t. And we got to solve this thing for 0.02t, or for t. So divide by 800, you get 9/8. So you get ln of 9/8 equals 0.02t. So on my calculator, ln of 9/8. And then I'm just going to go ahead and divide on here. Divided by 0.02, same as multiply by 50. It gives me t equals 5.889 years.